Fractional replication is a method used by statisticians to simplify the process of experimentation by cutting down on the total amount of trials needed to complete a study.
2p factorial experiments are experiments in which multiple factors are being tested simultaneously, with each factor having two levels or values. The goal of the experiment is to determine the effect each factor has on the outcome of a test. In order to determine whether a change in outcome is due to a certain factor, each factor at each level has to be tested with the other factor level combinations. An experiment with p different factors being tested requires 2p different experiments in order to test each combination.
In fractional replication, you subtract from the exponent by k, which is the value that you determine. The higher the value of k, the less trials you need to complete for the experiment. When k equals 1, the experiment size is halved. When k equals 2, the experiment size is quartered, and so on. However, this also means that the experiment is less accurate because you're cutting more data from it. With 2p factorial experiments, the amount of possible replications can increase beyond a manageable amount. Therefore, to cut down on this, the fractional replication is used to create a more effective and cost-efficient dataset. With the graphs, the alphabetical letters are seen are the variables used in the experiments. The negative and positive ones are the values that are given to each of the variable sets. When you observe the variables, you'll find that some of the variables fall into the lower level interaction and therefore can be removed to provide more space.
In this example, the experiment is testing 4 different factors of plant growth: temperature, sunlight exposure, pest control, and water supply, in order to determine the effects of each. With each factor having 2 levels, 16 tests are required to test each combination of the 4 factors. If you have a small space or limited supply of plants and can only have 8 tests, a 1/2 fractional replication will allow you to complete the experiment under the constraints.
However, a problem arises when you commit to using fractional replication. The p factor, the amount that you're cutting out, decreases your accuracy because there is less data that might be relevant. Soon, should you decide not to reduce the fractional, you find that the additional bonus of accuracy won't matter since the amount of data you'll go through will cost too much. In the end, it's about finding the right amount of fluff to remove so that your workload is manageable while maintaining accuracy.
After determining whether each variable is higher level or lower level, you'll have to remove the lower level interactions as they don't impact the results as much. An easy way to imagine this is like making notes based off a chapter in a book. You don't necessarily need all of the text in the book, but you don't want to remove so much that it doesn't have the important information and main ideas.